In 2016, astronomers discovered a small object orbiting Earth, now known as 469219 Kamo'oalewa, or simply Kamo'oalewa, which is often referred to as Earth's new moon or as quasi-satellite. Although it's not a true second moon in the strict sense, Kamo'oalewa's behavior and orbit make it unique enough to earn this nickname. Kamo'oalewa is classified as a near-Earth asteroid NEA, approximately 40 to 100 meters in diameter. Its name comes from the Hawaiian language, meaning the oscillating celestial fragment. Unlike Earth's true moon, which has been orbiting the planet for over 4 billion years, Kamo'oalewa follows a different, more complex orbital path. It is a quasi-satellite because it shares a similar orbit with Earth, staying relatively close, but it doesn't orbit the planet in the same way the moon does. Kamo'oalewa orbits the sun in a pattern closely synchronized with Earth, meaning its path is tied to Earth's own orbit. Unlike the moon, which orbits directly around Earth, Kamo'oalewa orbits the sun but stays in the vicinity of Earth, which creates the illusion of it accompanying our planet. Proximity. Kamo'oalewa remains between 38 to 100 times the distance from Earth to the moon. This distance fluctuates over the course of its orbit, and while it stays near Earth, it never gets close enough to be considered a true satellite like the moon. Period of orbit. It takes Kamo'oalewa about 365 days, similar to Earth's year, to complete its orbit around the sun, but its orbit is slightly tilted and more elliptical than Earth's. This tilt and eccentricity create a looping effect when observed from Earth, making it appear to move in a complicated spiral-like path. Temporary nature. Kamo'oalewa has likely been in its current quasi-satellite orbit for a few hundred years, and it is expected to remain in this state for only a few more centuries. Eventually, gravitational interactions with Earth and other celestial bodies will alter its trajectory, and it will no longer remain in Earth's vicinity. The exact origins of Kamo'oalewa are still unclear, but it is believed to be either a fragment of a larger asteroid or a piece of debris from the moon itself, perhaps knocked off during a meteorite impact. Its spectral characteristics, particularly its reflection of light, are similar to lunar rocks, suggesting that it may have a connection to the moon's surface. Some other theories suggest that it could be a captured asteroid from elsewhere in the solar system. The term new moon has traditionally been associated with the lunar phase where the moon is in conjunction with the sun, rendering it invisible from Earth. Kamo'oalewa has earned the moniker of Earth's new moon or mini-moon due to its orbital proximity and the fact that it remains close to Earth for significant periods. However, because it orbits the sun rather than Earth, it isn't a true moon in the same sense as our familiar natural satellite. Instead, it follows a path that keeps it near Earth but bound to the sun. Kamo'oalewa was first discovered in April 2016 by the Pan-STARRS 1 telescope in Hawaii, a facility known for its work in scanning the sky for asteroids and comets. The object was initially classified as a near-Earth asteroid, NEA, and was later given the designation 469219 Kamo'oalewa. The name was chosen from Hawaiian mythology, where Kamo'oalewa means oscillating celestial fragment, a fitting description given the asteroid's looping motion relative to Earth. The discovery of Kamo'oalewa highlighted the existence of small bodies that closely follow Earth's orbit around the sun. Though tiny compared to Earth's true moon, this asteroid opened up a new area of research into near-Earth objects and their potential origins. Kamo'oalewa is what astronomers call a quasi-satellite, a special type of co-orbital object. This means it doesn't orbit Earth in the same way as the moon but instead orbits the sun in a path similar to Earth's orbit, which keeps it near Earth for long periods. Shared orbit with Earth. Kamo'oalewa orbits the sun in an almost identical period as Earth, about 365.89 days. While its distance from Earth varies throughout its orbit, it stays relatively close, usually between 38 and 100 times the distance from Earth to the moon, roughly 15 million to 40 million kilometers. This motion creates a kind of partnership with Earth, although it does not directly orbit the planet like a traditional moon. Complex path. The asteroid follows a complicated spiral pattern when observed from Earth, making it appear to move back and forth in relation to the planet. Kamo'oalewa's orbit has an inclination, tilt, of around 8 degrees relative to the plane of Earth's orbit, meaning it moves both above and below the orbital plane of Earth as it orbits the sun. This gives it a dynamic trajectory. sometimes appearing to lead Earth, sometimes to trail behind it. Temporary nature. Unlike Earth's moon, which has orbited the planet for billions of years, Kamo'oalewa is a temporary companion. Simulations suggest it has only been in its quasi-satellite orbit for about 300 years, and it is expected to remain in this state for another few hundred years before gravitational interactions with Earth and other celestial bodies will send it off into a different orbit. These interactions include influences from the Moon, the Sun, and even other planets in the solar system. One of the most intriguing aspects of Kamo'oalewa is its origin. While it is classified as a near-Earth asteroid, there are multiple hypotheses about where it came from. 1. Captured asteroid. The most straightforward explanation is that Kamo'oalewa is an asteroid that was captured into its quasi-satellite orbit by Earth's gravity. This type of capture is a rare but not unheard of event in celestial mechanics. Objects like Kamo'oalewa can be influenced by the gravitational pull of planets, leading them into temporary orbits near those planets before they eventually drift away. 2. Lunar fragment. Another hypothesis is that Kamo'oalewa could be a fragment of the Moon itself, possibly ejected during a massive impact event. Scientists have noted that the spectral properties of Kamo'oalewa, the way it reflects sunlight, are similar to lunar rocks, particularly those from the Moon's highlands. If this is the case, Kamo'oalewa could represent a small piece of Earth's history, having been blasted into space millions of years ago, only to return to a close orbit around its home planet. 3. Captured solar system debris. Another possibility is that Kamo'oalewa is part of the broader population of near-Earth objects that originated from the asteroid belt between Mars and Jupiter, or even further out in the solar system. Over time, gravitational interactions with planets like Earth could have nudged it into its current position. Kamo'oalewa's unique orbit and proximity to Earth make it a valuable object for study. There are several reasons why this quasi-satellite is of scientific interest. 1. Near-Earth Object (NEO) research. Kamo'oalewa is part of the Near-Earth Object (NEO) population, which includes asteroids and comets that come within close proximity to Earth. Understanding its orbital behavior helps scientists study the dynamics of such objects, which is important for predicting potential asteroid impacts and developing strategies for planetary defense. 2. Potential space missions. Because Kamo'oalewa remains relatively close to Earth, it is a potential target for future space missions. Exploring such objects up close could yield valuable information about the composition of NEOs and their interactions with Earth. Moreover, missions to Kamo'oalewa could test spacecraft technologies in preparation for longer-term missions to other asteroids or even Mars. 3. Lunar connection. If Kamo'oalewa is indeed a fragment of the Moon, studying it could provide insights into the history of the Earth-Moon system. Such a discovery could offer new information about the history of impact events on the Moon and how material from these events has been scattered across the solar system. 4. Celestial mechanics. The study of Kamo'oalewa's quasi-satellite orbit is crucial for understanding how small objects interact with planets over long periods. These interactions can offer insights into the broader dynamics of solar system formation and evolution, as well as the gravitational relationships between planets and small bodies. Though Kamo'oalewa is not a new moon in the traditional sense, its unusual orbit and proximity to Earth make it a fascinating object of study. Its temporary nature as a quasi-satellite of Earth, combined with its potential lunar origins, makes it an intriguing target for further exploration and research. Over time, as scientists study it more closely, Kamo'oalewa may help unlock new secrets about the dynamic history of our solar system.